Carpenter. We'll be talking to Nikki Weil, a solar scientist from NASA.
Welcome back to Salem, Oregon. It is clear, but yes, it is a little bit breezy
it's
here
windy,
today.
yeah.
Isn't it? Yeah. I'm joined again with NASA solar physicist Nicolene Weil.
Hi.
Hey, so why don't we just take a look at what we've got going on here now that transit is deep underway.
Yeah, so the moon is crossing in front of the sun, and it's kind of looking like the moon is taking a bite out of the sun. And if you guys have any colanders with you, like a kitchen colander strainer, you can actually see, if you let the sunlight come through that colander and look at the shadow on the ground below you, you'll actually be able to see the projected image of the moon taking a bite out of the sun down on the ground in front of you.
Oh, that's cool.
Yeah.
So you can just get something from the kitchen and share that with everyone who you're watching this with. That's great.
That's right. Now's the time to take out your pinhole cameras if you have those, or if you have those, the safety Eclipse glasses. Now's the time to get these out and make sure to look at the sun with these on.
That's right. You want to be watching safely. And I know we've been talking about it, but we really can't stress it enough. It's very important to be wearing these glasses.
It's just so amazing, though, to see the moon crossing in front of the sun. I mean, you never get to see anything like this.
So, are there some basics that you could share with us? I know we were trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So there's sort of three outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the atmosphere, the chromosphere and the corona of the sun. And we don't usually get to see those because they're so much less bright than the sun. It takes something special, like today's total solar eclipse, to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool. So I think what we're going to be doing now is sending it back to NASA's Eclipse Central in Charleston. Take it away, guys.
Thanks.
And welcome back to Charleston. You can hear these students are really excited for us. And I got to tell you, I had the chance to interview some of them just a few days ago. The College of Charleston students are excited, and I wanted to find out what they knew about the eclipse. Let's watch the video.
All right. So right now what we're looking at on your screen is
Hello, I am Karen Fox with NASA TV. I'm here at the College of Charleston in Charleston, South Carolina, and we are going to spend some time interviewing students to find out what they know about the total eclipse of 2017. What's happening on Monday?
The solar eclipse is happening.
Monday, the eclipse.
That's the right answer, the eclipse. Are you ready for the eclipse?
Oh, I'm pumped. I've been talking about it all summer.
What is an eclipse?
When the moon moves in front of the sun.
It's when the moon passes in front of the sun and creates a shadow on Earth.
What is the closest star to Earth?
The sun? The sun?
The sun.
The sun? Yes, the sun! Very nice. Will you demonstrate for me putting these on?
We're going to put them over the glasses.
The music you associate with the eclipse. What have you been listening to? What are you going to listen to?
Here comes the sun.
Total eclipse of my heart.
Do-do-do-do.
Da-na-na, like, I saved every letter you wrote me.
So I was really impressed with how much these students knew. We had a great
actually understand the corona is very important because all sun-like stars have the corona. We need to understand why the energy is released in the way it is.
All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
And as it goes up in the air, you see the balloon and that parachute attached. That is what's going to let that get safely down to the ground.
And all those instruments
strung
out along there.
Attached as well. That's a beautiful sight.
Okay, can you hear me okay, right? Yes. This is Kevin Boucher. Sorry about the little mix-up. I was too enthralled. I was too enthralled looking at this fantastic weather balloon that has just launched. You can probably see it behind me. It is pandemonium here, but it's good pandemonium. One of the weather balloons has launched, and with me is one of the team members. Introduce yourself to the entire world. No pressure.
Hi, my name is Colleen Fava. I'm the program manager for the Louisiana Space Grant Consortium based at LSU.
Okay, so just to kind of keep a scorecard for people if they're wondering, we talked to, I guess, the program director, Dr. Gregory Guzik. He is your boss.
Yes, he is my boss.
What exactly does your job entail with this consortium?
I manage the program, so I write grants and reports and organize students and keep them on track, and I do communications training.
Sounds like you do a lot of outreach as well, and it thrills my heart, and I'm sure it thrills your heart to see so many of these young people. You probably did not have to drag these young people kicking and screaming to do this help, did you?
No, we brought 4 institutions with us, and LSU is the home team, and so they were always coming, but we actually had a competition to figure out which other students we would bring, and we brought a team of 46 people.
Okay, and right behind you now, I had forgotten they're launching 2 balloons. Now the first balloon, I think we have a video of the first balloon.
Right on top of it here, just a few more seconds.
Okay, we're getting ready to launch the second balloon.
Watch this balloon.
Both of our balloons launched already. That's
okay.
the first balloon, another.
The first balloon, Colleen, that was launched, where is it right now? Maybe 2,000 feet, you think?
They go up about 1,000 feet a minute, so a few thousand. It's probably been a couple of minutes now.
Okay.
So.
There it goes. This other one has launched. It's a big yellow balloon filled with helium. And the next time we see this balloon, we'll be down on the ground and it'll have wonderful data. Can you tell us about what goes into studying the winds and the weather reports, trying to calculate where this will land so you can quickly retrieve it and get your data? That's a whole nother science.
Yeah, so I'm not an expert on it. I can just tell you that we do our predicts. We started our predicts months ago, doing them maybe every week or so, and then the last few weeks we've been doing predicts every single day. So we have a good idea. We think it'll go about 36 kilometers, about 22 miles due east, somewhere near Marion. So we'll have several chase vehicles kind of staged and ready to go, and I'm not sure if they decided to leave before or after totality, but we have some local people helping us to make sure we have access, and we're hoping, expecting to be a pretty easy recovery.
Now, will you actually be on the chase team yourself?
No, I'm not going to be on the chase team. I need to do logistics here on the ground. I have been on a chase though, and it's very exciting.
Oh, I'm sure. Yeah, can you tell me about it? And please get as specific as you can. What are some of the most eventful ones? Like, has the balloon ever come down in
Pontchartrain River?
How did you know? You're not kidding me?
I'm not kidding you. We did have a landing in the Pontchartrain River, which was not a great recovery, but it was definitely better than landing in the airport, which we were afraid was going to happen.
Well, I was going to say I would rather land in an airport because the Pontchartrain River, you have the water that might damage some of your instruments, but you're the expert then, right?
I think we'd rather not interfere with air traffic control.
That's true. Landing in a Pontchartrain River, and I assume the alligators did not make a meal out of your several $1,000s worth of instruments?
We didn't recover that payload, but we have done water recoveries in the past, and we actually just invested in an inflatable kayak.
Okay. My producer just told me we are seeing first contact. Everybody, we have people putting on their glasses the first contact. We are seeing the first contact, and we've got about 4 minutes left. How many total solar eclipses have you seen, Colleen?
This is my first.
I assume you have your glasses. Right. Feel free to go ahead and put your glasses on.
You want a pair?
Yes, please.
Your fingers together, you can make little spaces in between your fingers.
If you don't mind, I'm gonna.
You can project little images of the eclipses down onto the ground. So make sure you look down just as much as you look up.
You can't really see through
also,
them.
If you
Right. Okay. My glasses are on. Are your glasses on too?
They are on.
Okay. And the sun. We are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Oh, okay. I'm going to turn my back to the camera. Oh my gosh! There is a small bite starting in the sun. What are your comments?
I said that is gorgeous,
because of
isn't
these
it?
ripply shapes you see on the ground.
That is fantastic. The total solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer, I can take these out. I will go to the solar, I think it's the Dynamic Observatory that often will give videos of the rotating sun. And Colleen, I don't know about you, but when I see that giant ball of gas just rotating, majestic is a word that comes to my mind. Could you agree?
I absolutely agree. It's amazing, and I think that we're really fortunate to have this opportunity and to be in community with our students and faculty and staff from multiple institutions here at SIU, who's been wonderful and very welcoming. It's just extraordinary.
It sure is. Thank you very much for your time. Keep up the great work. Thank you for talking with us. That was Colleen Fava with the LSU.
Thank you so much to Carbondale.
Thank you, Carbondale. That was amazing.
It's great, and I love looking at those images and how you can see different things at different parts of the country. It's wonderful to be sharing this imagery with all of you. We will have more from Carbondale later today. Please stick with us. We have so much coming up.
From there and from here at NASA's Eclipse Central here at the College of Charleston.
of communications. And over the next 3 hours, we're going to look through the eyes of NASA and experience today's total solar eclipse. I have a great team here on stage. Joining me to my immediate left is Jadi Collado Vega, who is a space weather scientist. Solar scientist next to her, Alex Young. Over to my right, John Yimbrick, who will be taking your social media questions today, plus media specialist and meteorologist, very important man today, I must say. Tracking the weather conditions across the path of totality, Sean Potter. Today, we're coming to you from NASA Eclipse Central here at the College of Charleston. Now, Charleston is the last stop of the total solar eclipse on U.S. soil. So we will track
We really appreciate it. I know you got to get going.
Yeah, thank you.
It's coming soon. And joining us now to talk to us about the sun and give us more information is NASA lead scientist for Eclipse 2017, Madhulika Guhatakurta from Ames Research Center. Hi, Lika.
Hey, Jesse.
Hey, it's almost here. It's almost here. So, how many eclipses have you seen?
I went to see 9 eclipses, and I actually landed up seeing 6. The other 3 had inclement weather.
Oh.
We don't have that here today.
No, we don't, and it's going to be 7. So, what can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now, and whatever I say, kind of take it with that filter because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfing, generating this environment called space weather. The inner edge of the corona that you see that's black in the video is because the sun is so intense that it overwhelms the dim brightness of the corona. And so even from space, we can't absorb the inner part of the corona. And not only Earth, but the entire solar system, as you can see, lives with this dynamic star. Corona is the region where space weather is born and conditions are set for a supersonic solar wind and a super hot corona, 2 of our outstanding questions in heliophysics, in physics, really. To understand the corona better, NASA is actually going to be launching a mission next year, almost a year from now. How coincidental, called Parker Solar Probe. It is actually going to go touch the sun, and it's going to get closer to any other spacecraft has gone before to the sun to study the corona, to actually sample the very corona that we will be seeing very soon.
Yes, we will. It's almost here. Thank you. Thank you, Lika, for joining us, and thank you for sharing that. So now we're going to take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, just now coming in, we have an exclusive sneak peek of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view.
Wow.
And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon, where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
Oh my God, that's so pretty.
That's the G3 there. Okay.
That's breathtaking.
Is that the real thing? Is that the real?
It's amazing.
Okay. We're going to keep that up, and then we're going to do reactions. Okay, so
as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got? That looks pretty cool.
I mean, it's breathtaking. Even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, Sean, and, get that weather up here looking good here in Charleston. Now, what do we...
So, Alex...
Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright... Actually, the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So, Alex, a reminder, Alex, so when that diamond ring pops up, that's what people should put the
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the origin. That is where the origin of space weather. That's where it comes from.
That's where most of the solar flares and the corona mass ejections, big explosions of particles, originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's the diamond ring again. That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juiced. They got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
gasping.
Completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No,
It's
what's
coming out.
happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're going to see something like this today, and you saw it. But you're going to see it better because nature does it better than we can actually do it artificially. Right now, the activity is not, there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls? In Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird we have a crescent sun instead of a crescent moon. This is the... I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago. And things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho. And they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Steber. Hey, Richard. He has been manning this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a place, a school in Southern California. Take a look.
think we're going to come back to you, okay? I apologize for no audio.
All right, we apologize. There is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a solar system ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right, and watch, and we can talk. All right,
oh,
so
what
we
a
still
little sliver.
Just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth sun line is tilted by 5 degrees. And so there's only 2 places where the moon and the Earth and sun are on that same line. And that's why every 18 months or so we get an eclipse.
The shadow is 1 minute out of Idaho.
1 minute away. Wow.
The crowd is getting excited.
Wow. It's already so eerie.
Wow, it just got dark all around us. And you can feel the temperature getting colder here.
Oh, yeah. The winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can... It's just a tiny, tiny sliver right now.
It's a 360-degree sunset. If you can see, and the shadow is now sweeping in from the left.
It's all closing up.
There it goes. It's going. Getting smaller. Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh, wow.
There's Venus. Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah, wow. Wow.
We should turn off the lights.
All right, have to get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on around
the street
us.
lights turned on,
We
of course.
confused the street lights.
Of course. Who would have thought? That we didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay, there it goes. There's the diamond ring. There's the diamond ring.
Oh my gosh.
Yeah, wow.
That is
Was
so...
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
Well, it has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Well, Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So, Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Okay, so we're gonna come back to you, and we're gonna talk about what's happening here. So the next up, NASA's ready to take a bite out of the Big Apple, one of my favorite cities, Jody, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm going to turn to you. You know, New York, they're going to get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabukin, the Research Administrator for the NASA Science Mission Directorate. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
Ready as I'll ever be with this.
And we're back here at the G3 up over the Pacific Ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years, I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about two things. First of all, the shape of the corona. You know, I saw the models. I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you can turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over is another line, red. Well, what is that? Well, it's hydrogen. Well, so even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
Yeah, so it was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. And as we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains, but it was all the darkness, and it was just stunning to me to see that. So really, really good stuff, and I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed, some fantastic images we've already looked at that I can't wait to share with everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows? What?
Okay, all right. So now let's go to the NASA Marshall Space Flight Center. Chris Blair standing by.
Humans are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us more is Dominic Critchlow from Austin Peay State University. Thanks for joining us. We appreciate it. So tell the crowd and our audience a little bit about the scientific payload you have on board.
Yeah, thank you for having me. Today we're flying some still image equipment, and we're going to be taking images of the ground in different wavelengths. And we're also flying live stream streaming equipment so we can live stream the eclipse looking downwards and looking around and at 100,000 feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA Ames and then our trackers so we can have a successful recovery.
Okay, and they've just released your balloon, so let's talk about the NASA science and the biological samples. Explain more.
So NASA Ames has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool. We are very excited about that. And so also, how many balloon releases are you planning on doing this today or this weekend? So all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have a full coverage of the stream. And on the site today, we have 3 launches from 3 different universities. And we're just really excited to be here and hopefully all successful launches. All right, so finally, these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country? What's a tip you would tell them? If you find it, leave it there. Maybe take a picture because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it. Awesome. Thanks. We appreciate your time. Thank you. Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
Well, the students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the Inspire project as well. They're participating in VLF radio noise experiments, and those folks are from Washington, D.C.
All right, excellent. So you mentioned the Space and Rocket Center, Space Camp. That's the official visitor center for NASA's Marshall Space Flight Center. Feel free, if you're in northern Alabama, to come and see us. They do a great job of representing a past, future, and present history of NASA. So any parting words?
Well, you know, in the words of Frank Reynolds, I'd like for us to remember for the next American eclipse in 2024, let the shadow of the moon fall on an earth at peace.
Very poetically done. We appreciate it. All right, so up next is, as promised, our Animal Lovers segment. And so here on the agricultural farm, students are studying a really cool STEM field. So it's conservation management, it's veterinary medicine, animal biology, and so they're interested in animal behavior. And so joining us is Dr. Donald Sudbrink, head of the Ag Department here at Austin Peay State University. And so it's not cow tipping, it's cow painting, correct?
Yes. We had to paint the cows that are in this study to see what sort of things that they would do so we could record the individual animals so we could see what behaviors that they were exhibiting.
So we saw the cows, and the students were involved with that Mitzi just spoke about. And we're also talking about cricket behavior and cricket observations.
Yeah. Yes. Well, we're also talking about crickets. I'm an entomologist by training, and crickets generally chirp at night. So we're going to get a chance to see a series of isolated males and see what they do when the sun goes out.
Okay, excellent. Well, glad you all are doing this kind of observational research. Really appreciate your time.
Thank you.
Thanks a lot. So, and speaking of time, it's almost time for us, everyone here at Austin Peay State University, to actually watch the solar eclipse. So let's go back live for continuing coverage of NASA's eclipse across America from Charleston.
Okay, so Yadi, I wonder if the milk tastes better when you paint the cows.
I don't think so. I don't think so.
All right, let's go to social media. We've been in the show here, and I know it's a buzz. So over to John Yimbrick for social media update.
Yeah, last time I looked, Dwayne, there were 2.1 million people looking online on our website. On our 1.2 on our live stream, so it was a huge conversation. And Solar Eclipse 2017 is still trending #1 on Twitter, so it's been huge. Can we go to the first slide here that I've got up? This right here is an amazing photo. Sometimes they say you have to be at the right place at the right time. This is taken by one of our NASA photographers, Bill Ingalls, out in Washington, and he captured. It's hard to see here in this pic, but he captured the International Space Station transiting the sun during the partial eclipse there in Washington. Pretty amazing. You kind of have to look closely. We'll also be putting these images up online if you want to see them. But one of those little dots there is the International Space Station traveling at 17,500 miles per hour. Here's another one from our photographer in Wyoming. Same concept, capture the space station. We knew exactly when the space station was going to be flying, what its orbit was, and when it was going to cross the sun. And look here, it's just an amazing sight. I'm really proud of our photographers for getting these shots and proactively trying to get something that no one else probably has and thinking through and getting this great image. So let's take a few questions from social media. I want to remind our viewers at home that you can ask questions to us here on the set and on social media with the hashtag Eclipse 2017. So why don't we bring it back here to the stage. First question is from Twitter. What if we wear sunglasses instead of eclipse glasses? Will we actually be able to see the eclipse? The sunglasses help? Does it give you any sort of protection?
No, that's definitely a no-no. You should not wear sunglasses, normal sunglasses. Always wear the actual sunglasses that are made for solar viewing, like the ones that I'm having here right now in my hand. And if you don't have the sunglasses, you never look directly at the sun. You look like you do an indirect projection of that eclipse. Never look at the sun without the proper safety.
So another question here comes from Deborah from Facebook. So the sun rises in the east and sets in the west, and the Earth rotates in clockwise motion. Please explain how it starts in the west and ends in the east.
Well, so the Earth is rotating from west to east, but actually the moon is moving faster, about 3,400 miles an hour, casting a shadow down on the Earth, which is rotating at about 1,700 miles an hour. And that actually means that the shadow is moving from west to east across the Earth at about somewhere between 1,200 to 1,800 miles per hour, depending on where you are on the Earth.
Okay, great. We have another one. I think we have time for another one. Tina from Facebook's asked, if I place a lens from the eclipse viewing glasses over a viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
Yeah, you can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
Okay. This is Mickey from Facebook. Hey, NASA, can the International Space Station see the shadow of the moon crossing America from space? Do they have that view when they're looking from space?
They do, and that's what we're hoping to see from them, yes.
Excellent. So, John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Right, thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of totality, casting a large shadow on Earth's surface. Now, the footage you're seeing right now shows a solar eclipse that occurred in March of 2016 over Indonesia. That experience helped us determine how best to study today's eclipse. These images were taken by NASA's EPIC instrument aboard NOAA's Deep Space Climate Observatory, or DISCOVER. It's just one of the instruments we'll be using today to study the eclipse as we monitor changes in Earth's energy balance. Scientists have made extensive atmospheric measurements during eclipses before, but this is the first opportunity to collect coordinated data from both the ground and from a spacecraft that observes the entire sunlit Earth during an eclipse. Dwayne, back to you.
Thank you, Sean. Okay, so now we have a special guest with us today, the Associate Administrator for NASA's Office of Communication, Jinray Wong. Jinray, welcome.
Dwayne, thank you. So happy to be here.
Oh, it's an exciting day.
It's a
I'm glad
wonderful
you're
day.
to join the team here. And our next location you are pretty familiar with, I'm sure.
I am very blessed, and I do know something about the great state of Nebraska. I've actually lived there for the last decade, and I have friends and family who are watching there from the path of totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their glasses, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the path of totality. It's also a really exciting day for NASA. And in fact, this gives us an opportunity to look forward as well. And we have a future study that we are going to be doing for to study the sun. NASA is going to launch a new spacecraft next year, the Parker Solar Probe, and it will fly directly into the solar atmosphere. The mission will provide first-of-its-kind data. And for more information on this future mission, let's go to Beatrice, Nebraska, where Vince Whitfield from NASA's Langley Research Center is standing by. He's at Homestead National Monument, where the National Park Service has coordinated an eclipse viewing. Vince?
And just in, I think we're having, Vince is going to come up shortly, Jen Ray, so we're going to go back with an image, but we will be doing Nebraska as soon as we can. So a shout out to the great state.
Thank you. First shot.
Okay, folks, Jody and Alex, this is a different view here. What are we seeing, Alex?
Well, so we're looking at a different wavelength of visible light. It's called calcium K. So this is light that's produced by excited calcium. And this is showing us the sun as the moon is moving over it. And in fact, if you look over to the left on the edge of the sun, you actually see sunspots.
A sunspot, yeah.
And these are regions that heliophysicists like myself and Jari are most interested in, because that's where solar explosions originate from. In fact, the magnetic fields that come up into the corona that we see during the total solar eclipse originate from those sunspots.
Yeah. Actually, this sunspot had a solar flare yesterday.
Right, and I believe this is coming from Carbondale. So that's, now it's why is it purple? Is that, what's the color mean?
That's actually the light, and the color of the light in the filter. The color is a bluish light, and so it comes out as a purple color. But it is a type of visible light, and it's one we look at quite often from both space and the ground and look in the sun.
Now I see some black thingies, look like a little river. You see it over there near the corner on the left?
Yeah, that's the sunspots.
Now, what's a sunspot, just for our audience here?
Those are the regions where most of the space weather actually originates. The solar flares, the coronal mass ejections are regions of the sun that have very complicated magnetic fields. And these are where most of the magnetic energy is actually released.
Right, so those are regions of super intense magnetic field, 1,000 times stronger than the Earth's magnetic field. And those have lots of energy, and they drive space weather.
Okay, I think that's why we didn't get the Nebraska feed right now. Those things cause that, I think, right?
That's right. We're getting a little glitch.
Hopefully we get Nebraska. Okay, Sean, we're going back over to you. We'll talk about moon shattering.
That's right, Dwayne. We've got some really incredible imagery for you. This is again from the GOES-16 weather satellite, just launched last year by NASA for our friends at NOAA. And what you're seeing in the western portion of this image is actually the moon's shadow being cast over parts of the path of totality. And of course, you see the cloud cover across the U.S. as well. And as I was telling you earlier, it's actually looking pretty good for most of the western parts of the U.S. that are in the path of totality. Not so good for maybe parts of the central U.S. Where we've got some thunderstorm activity developing and expected to develop later today, this afternoon, for places like Nebraska, parts of Nebraska and Missouri and northern Illinois, so maybe north of Carbondale. And then gets better again as you see in terms of cloud cover as we move further east toward Charleston here. But here in Charleston, we still have some breaks in the cloud. Where the sun is, it's still obscured, but we are able to actually see some of the partial eclipse here in Charleston through some of the breaks in cloud. But again, really wanted to show you guys that imagery from GOES-16 satellite from NOAA showing you the moon's shadow actually being cast over parts of the western United States right now. With that, Dwayne, I'm going to hand it back over to you.
Thanks, Sean. Now, as a reminder, our broadcast is tracking the total solar eclipse as it crosses the United States. It's moving along a path of totality. That's a 70-mile wide path sweeping across the entire nation. Over 12 million people live inside the path of totality, plus it's estimated that close to 7 million people have traveled to cities within the path of totality. I know that today is truly a day of celebration as people gather in cities and festivals to view today's celestial event. So let's get into the cultural impact here, guys. Alex, what's your take on the cultural impact of these eclipses?
Well, you know, this is really such a fantastic opportunity to connect the nation and, in fact, the world with one of nature's most amazing celestial events. And this is something that we, as working at NASA, are really excited to be able to share. And in fact, We've even worked with some of our colleagues in other parts like the U.S. Postal Service.
Yes, the U.S. Postal Service actually create a special stamp for this event.
Right. So what I want to do, let's talk about the stamp.
Sure.
But Generate Charleston, Nebraska, the sunspots are gone, so let's go to Nebraska. Vince Whitfield, are you there?
Hi, we're at the Homestead National Monument of America. This is a great location to watch the eclipse, and we've staked out a good spot here on the prairie. Even though the weather isn't cooperating, this is still an excellent event. We're also very prepared. Please make sure to use your protective glasses when viewing the eclipse wherever you are. You can cause serious damage to your eyes if you don't take precautions while watching. And there are a lot of people watching. As you can tell, the festivities, just like the eclipse, are in full swing. I'm joined by Chief Park Ranger Susan Cook.
Hey Vince, how are you?
Great, Susan. Thanks for joining me today. Please tell us about this amazing place and what's going on behind us.
Well, we are at Homestead National Monument of America. We are a national park site dedicated to telling the story of homesteading. 30 states, 4 million people, 10% of the United States was homesteaded. The head of a household, anybody could own land as long as you could be a U.S. citizen. You got 160 acres. It's how we settled the West. We built our democracy, we built our economy, settling the West through this law.
That is just so interesting. Now, I understand the Mayan calendar followed the solar eclipse calendar closely. Is that correct?
It did. The ancient Mayan used several different calendars to organize their secular and spiritual lives. Many of these calendars had strong roots in the motions of celestial objects, especially the sun and the moon. And the Hub calendar is a solar calendar of 365 days, subdivided into 18 months of 20 days, plus 1 month of 5 days. Another calendar is a Tzolk'in made of 260 days, subdivided into 13 months of 20 days. This calendar also has a resonance with eclipses, which occur about every 173 days. Every 3 sequences of eclipses aligns every 2 cycles of the Tzolk'in. Who could keep track of that, frankly?
It's just amazing. Now, as a Chief Park Ranger, I have to congratulate you. This is a fantastic venue. Tell us about some of the activities you have planned.
Well, actually, right now you can feel it getting darker, but we have stage performances going on. We have many NASA scientists. You can learn about planetary defense, how we defend our world. You have NASA scientists doing other things. We have Native Americans. We have a Mayan Calendar in the Sky program. We have folk music. We have all sorts of fiddle music.
Lots going on.
Lots of things, balloon launches. So there's things all around us. It's really exciting and a lot of fun.
Got to say, the amount going on here, Susan, is incredible. Thank you so much.
Thank you very much. Thanks for being here.
Absolutely. And we're lucky enough to be joined by a real NASA scientist. Let me introduce you to Dr. Nikki Fox.
Hi, Vince. How are you today?
Great, Nikki. Thanks for joining us. Nikki is a space weather expert and a mission project scientist on NASA's Parker Solar Probe program. Thanks so much for joining us, Nikki. Today is a great day for you. Tell us why.
Well, today I'm really excited. This is my first ever solar eclipse, and it's the only chance that we can see the corona with our naked eye. And I'm particularly excited because I'm working on NASA's Parker Solar Probe mission, and we are going to fly into the corona. So if the clouds part here, you'll be able to see where our mission is flying.
That's just incredible. Now, how close will you get to the sun?
We will get to within 4 million miles, and I know that doesn't sound terribly close, but if I put the Earth and the sun apart on a football field, then we would be at the 4-yard line.
That's just amazing. Now, for you watching at home, that's kind of like traveling from Washington, D.C. to Philadelphia in about 1 second. Just incredible speeds. Now, how can you be so close to the sun and not burn up?
So we have a wonderful heat shield, but we also, the technology, it's been 60 years since this mission was first thought of, and it's only now that technology has caught up with our dreams.
That's just amazing. Now, it looks like we're coming up to the moment of totality here on the prairie. What are some of the things we should be looking for?
So if it clears, you should see a beautiful corona, and that it looks like a pearly, hazy crown around the sun. And in fact, it's called a corona because that's Latin for crown. And then as it's going beautifully dark here, it's becoming twilight. You hear everyone going crazy here. You should be able to start seeing stars, and we can actually see 4 planets. This time you should see Jupiter, Mercury, Mars, and Venus all in this night sky during the day. So it's just an amazing, amazing experience. And if you can't see the corona, I do have a map of it here. This is a 3D print that was done for me, and it looks exactly, it's a predict of what the corona looks like today. So If it's cloudy, here's your corona.
Now, it looks like the moment of totality is upon us. Let's just take let the guys at home have a few moments to take in the sights and sounds of the crowd as totality happens on the prairie.
Oh, wow. And you can see the corona, and I may cry, but you can see the corona. So now you're seeing this wonderful hazy atmosphere. I don't need my glasses now, Vince, because we are in totality.
Wow.
And so this is the only time that it's safe to look. But right now you can see that hazy ring. That is the chromosphere. It is looking a little bit sort of reddish. And you just see there's those red wisps are little prominences that are coming away from the sun.
Wow.
Unfortunately, we can't quite see the stars yet because of the clouds. But my goodness, you can see the corona, and that is an absolutely incredible, incredible sight.
Yeah, this is just magnificent.
It really is. Everything's kind of, well, other than the people hooting and hollering here, everything else has gone quiet. The animals think it's nighttime. There's this amazing sort of twilight view all around us. And just look at that corona. That is incredible. Absolutely incredible.
Yeah, that's amazing.
Yep, and the moon is going to continue. We've got about 2 minutes, 35 seconds of this amazing view. And then here we come. Here comes the diamond ring. So it is glasses on again time. Glasses on. And here it comes. There's the diamond ring. And that is the most spectacular sight.
That's amazing.
That is just incredible. And of course the diamond ring you see because the moon is not a totally smooth sphere. And so you're seeing little spots of light peeping out between the craters on the moon. And my goodness, I'm sorry, I'm so excited. It's incredible.
Yeah, it's hard to convey the excitement of the energy. There are 10,000 people on the prairie here at the Homestead National Monument of America, and the energy is just amazing.
And they've been here, a lot of them have been here since 6 o'clock this morning, and the atmosphere has been incredible. Everybody is happy, and it has just been amazing.
That's just amazing.
Wow.
Okay, Nikki, let's bring you over to this side. It looks like the moment of totality has passed us here.
Yes.
Now, what should we be watching for in the moments after totality?
In the moments after totality, you will start to see again the Bailey's bead. So we did see that diamond ring, and I got super excited. But as the moon continues now to pass away, you'll start to see the solar surface come back. It's becoming light again. If we had any roosters here, they would actually be crowing. So it's just been it's amazing, and you'll start to see the sun coming back. And I don't know, I always think what it would have been like if you didn't know the sun was going to come back. You just thought it was disappearing, but here comes the sun again. So it's a wonderful, wonderful day here on the prairie.
That's wonderful. Nikki, what an amazing experience.
Yes.
Thanks so much for talking us through that.
I wouldn't be anywhere else, Vince. Thank you.
Thank you very much. What a great experience, everybody. That is amazing. Now, it looks like things are starting to calm down here on the prairie, but that doesn't mean the show is over. Our coverage of the path of totality continues across the entire path. So, let's go ahead and send it back to NASA's Eclipse Central.
Thank you, Vince. It was well worth the wait, my friend. We were a little delayed there, but my goodness. Jody, did you see that? I mean...
That was amazing. Do you see that diamond ring?
That was, it was even more prominent there.
It was very prominent. You could see like the ray of light, like very, very nice, and the whole diamond around the whole surface. It was amazing.
And Alex, it got really dark. I mean,
it really did. That's actually enjoyed seeing them out on that prairie and seeing. It looked like she was in some sort of weird, strange light, and she was lit up, and everything behind her was dark. It was really cool.
Fantastic. Nebraska, you rocking the house. We really, really appreciate that. But like Vince said, there's a lot more to come, and we got the International Space Station, don't forget. So, Jody, I want to go back. We had to bring in those images, but we were talking about, and you mentioned the stamp. Now, the United States Post Service, they do amazing work.
They do.
But they really outdid themselves this time. Go ahead and finish.
They did. They actually created a special stamp for this event. It's actually a thermochromic stamp, which means that it gets activated by heat, and you're actually looking at it now in your images. This stamp, if you put your thumb into the center, it will actually make the moon surface appear, or any type of heat that you apply to it. It's an amazing stamp, and I got mine yesterday thanks to Dwayne.
And it's thermochromic?
Thermochromic, yes.
Yes. Oh, wow.
It means it gets activated by the heat.
Yeah, heat of your thumb, and I bet you they sold a lot of those stamps.
Oh, they did. They sold out online originally right away. So it was quite a popular one. It's the first time the U.S. has ever used that type of ink.
Okay, so we have seen some pretty cool images. Still got some more to come.
Yeah.
The diamond has been prominent. Let's go over to social and see how things are going. John.
Thanks, Dwayne. We're continuing to look up here in Charleston, South Carolina, because there are some clouds here, and we're excited. Excitement we want to have here too as well. Just a couple quick interesting things. This is the biggest live stream event ever measured on NASA.gov. The web traffic is accounting for 87% of all federal web traffic, which is pretty amazing, showing that people are really tuning into our broadcast here. As of 1:40 p.m., 4.4 million people in climbing were watching this broadcast. So the interest across the country is obvious here, and we're going to continue to show you some amazing live views. This one right here is, again, another photo of the space station taken by Bill Ingalls in Washington, one of our photographers here at NASA. Next thing, I have a video from another photographer, one of our other photographers, as the space station transits. You can see it there. If you're looking closely, you can see the space station transiting the sun during the partial eclipse. Pretty spectacular. Again, that's 250 miles per hour, that space station. You have to be, 250 miles above the Earth, 17,500 miles per hour. You have to be taking a lot of different shots pretty fast to capture that. So nice job, Joel.
Okay, so let's go to Jefferson City. The moon shadow is continuing to pass over the United States in this remarkable celestial event. Our next stop on the path, as I said, of totality is Jefferson City, Missouri. We're going to hand off to meteorologist Eric Aldrich, who is a professor of atmospheric science at the University of Missouri. He has some special guests to help explain two important impacts solar activity can have on humans and the technologies we use. Over to you, Eric.
Okay, thanks a lot. Yeah, we are live in Jefferson City, Missouri. Jefferson City is actually the state capital, and as you can see behind me, there's a lot of people that are here. It's been a whole weekend type of thing, Saturday, Sunday, and of course here on Monday, lots of family-friendly things. There's been corn mazes, there's been 5K runs, there's a lot of good food. Too bad you can't smell the food, but there's a lot of good food that's here as well, and just a very nice weekend. The weather has been perfect. We've had some showers and thunderstorms off to the west all morning. We've had a few high clouds kind of stream on in, but certainly things are looking really good. I am lucky to be joined here by two special people that are going to be talking about space weather and just how things work in space. Dr. Janet Kavandi, thank you so much. You are the director of the NASA Glenn Research Center in Cleveland. Right. You're also a three-time shuttle astronaut.
That's right.
And you are actually from Springfield, Missouri.
I am.
Welcome home.
Thank you. It's great to be back.
Well, great.
Yeah.
So now, we've been talking a lot about safety, and obviously you don't want to look right up at the sun.
Not without these.
That's right.
Right.
And so we all have some, so that's good. But what about the astronauts that are up in space?
Mm-hmm.
What is there to help keep the astronauts safe from the solar radiation and so on and so forth?
Well, for their eyes, we know that they know that certain windows they should not look out of because there's no protection. Other windows have protection on them that help shield their eyes, but also there's other kinds of radiation like protons that come from the sun, heavier particles that can cause damage to our cells, and we try to shield the astronauts as best we can because they're above the atmosphere. We're shielded here by the atmosphere quite a bit, but above that you don't have that natural shielding, so we have to do it with metal in the vehicle and then some water bags around the sleep station so that they can sleep surrounded by water, and that also helps absorb some of that radiation.
Okay. Now, we also are kind of excited about space communications, and that's certainly another special research area. And so also with me here today is Dr. Tamitha Skov. Now, you're from the Aerospace Corporation in Los Angeles, so welcome to Central Missouri.
Thank you.
Now, you're also a space meteorologist.
Yes.
And you are also referred to as the space weather woman.
I am.
Right? So I've been intrigued by this. What exactly does a space weather woman do?
Well, most people don't realize that the sun actually has its own unique weather that comes from it. And those solar eruptions that come from the sun, they actually hit Earth and cause issues for us. So I actually do a weekly broadcast, weather predictions, just like you do, like a meteorologist, that talks about when these events hit Earth and the types of issues that they cause for things like communications, like GPS and other systems.
Okay, now we're just about 15 seconds away, actually, I believe, from totality.
Put our glasses on.
So we're going to put our glasses on. You can hear the crowd cheering in the background, and it is getting dark.
We're getting close to Bailey Beads. Here we go. We're almost at totality.
And
you can see
here
the
we
Bailey
go.
Beads, almost the diamond ring right there. And there we go.
incredible. Now, Dr. Cavande, you've been in space. You've seen numerous sunrises and sunsets from the space shuttle.
Yeah.
How does this event compare?
Oh, this is completely different than anything I've seen before. I never saw an eclipse. I've seen a partial, but nothing like this. This is really unique and nothing like I saw in space. Space has this really cool visuals, but this is really amazing.
You know, and I'm starting to hear the crickets. They're starting to come on out. Obviously, the street lamps. This is just amazing. Now, I'm also looking up to try to find the Big Dipper and some of the other stars, some of the other planets.
Not through the clouds, likely.
Right.
And I'm really mesmerized by this. This is a spectacular event. We've had several solar storms that have been launched, and some of them have been launched from the left side of the sun. So we're actually seeing a difference from what the corona looked like in our predictions to what it looks like now. And then on top of that, we have ham radio operators all over the state right now who are making contacts that they haven't been able to make because the upper atmosphere is just all turbulent right now, and it affects the communication signals. So we've got GPS operators and ham radio operators doing a ton of science, and it's just it's overwhelming.
This is amazing. Now, my team of atmospheric science researchers from the University of Missouri, they are actually sending up weather balloons here this afternoon to try to figure out, how the weather is changing at certain height levels. And actually, here's a map of the solar radiation throughout the state of Missouri, and you can kind of see how much solar radiation is hitting the surface of the Earth here in Missouri. Just interesting. This is amazing.
It is. You can tell the crowd is just mesmerized. This is so cool. And you can even see the dips in the valleys, as you can see little areas of the sun where it's shining through more.
Right, and those create the Bailey beads that we see as we get out of totality, which is coming up here pretty soon.
Right.
Not quite yet, though.
Yeah, I think we come out of totality at 1:15:35 local time, and so we just have a few more seconds of that. It's absolutely an amazing event, and again, we're so lucky that some of these high clouds were able to kind of fall apart a little bit, so we could experience this.
For us, yes, and I can't believe we can actually see the corona through the clouds.
Great.
Okay, that's the air horn. We're coming out of totality. We're going to have to end up.
So we need to put our safety glasses back on.
There we go. Put your Bailey beads. There we go. We got to put the glasses back on. Oh my goodness.
So as you can see, we're coming out of totality here in Jefferson City, Missouri. Ladies, thank you so much for experiencing this with me.
Thank you. Quite an experience. Thank you very much.
Yes, it was. Thank you. So everyone's excited here in Jefferson City, Missouri. The sun's starting to come out a little bit. We're going to go ahead and send it back to Charleston.
We should have stayed.
Thanks, Eric. Yadi, wow.
It's an amazing, I get goosebumps every time I see this. So I cannot imagine how it's going to be, when we actually see it here in South Carolina.
I mean, so Alex, I'm speechless, man. I mean, as a scientist, you got to love this stuff, right?
Oh my God, and it's so great to hear them. I mean, I love hearing an experienced astronaut talk about how overwhelming it is, given the amazing things that she has seen, but also to hear my colleague, Tamitha Scove, who is also a heliophysicist and a space weather expert. I can hear the excitement in her voice. I mean, it's palpable. It's just great.
Okay. So check this out, guys. I mean, I think things are going so smooth. We're going to go to another image right now from Hopkinsville. Brian Massey out there from Marshall Space Flight Center. What's going on? You got some action there. Hopkinsville. There it is.
That's beautiful. They're getting close.
Now, it's yellow. We had purple. Does that mean something there?
Well, the previous one we saw that was purple was calcium K. It was a blue kind of light. This is actually more of a white light, continuous. Yeah. But the thing to remember is sometimes the different filters you use will change the color just a little bit. But what we're seeing here is really more visible, broader spectrum white light.
Okay. White light.
Let me, John, you got to have some cool stuff on social media.
This is a good question, guys. Mark from Facebook's asking, and this is what really applies right now. When observing the moon at night, I see it proceed from eastern to western horizon, much like the sun does. How come the solar eclipse is traveling from west to east across the U.S.?
Well, again, that's because when we're looking at the moonrise, that's actually because of our location on the Earth and the fact that the Earth is rotating from west to east, the same reason that the sun rises in the east and sets in the west. But the moon itself is moving in the same direction the Earth is rotating, and it's casting that shadow down on the Earth, and that is moving in the direction that both the moon is orbiting and the Earth is rotating. So from west to east.
Okay, so the total eclipse has now passed over half the country. It's currently over Illinois, and I think we're going to have some views coming up shortly. But what I really want to do here, guys, is this has been really incredible. I want to give a shout out to the College of Charleston. Make some noise. Oh, we're loving it here. So now we've got live video coming to us from Hopkinsville, Kentucky. It's a small town that's known for southern hospitality, like Charleston, and it's also a prime spot for viewing this total solar eclipse. Hopkinsville is the city with the longest duration of the total solar eclipse, for a total of 2 minutes and 40 seconds of totality. NASA's Marshall Space Flight Center, Brian Massey, I'm so excited. What you got, man?
Dwayne, we're just as excited as you are. We are here in Eclipseville. Say hello, everybody. Oh, we're having a great time. I'm surrounded by 1,000 of my best friends. We're getting ready. It's starting to get a little darker already. We're also joined here by NASA Marshall planetary scientist Renee Weber. Renee, thanks for joining us.
Thanks. It's really great to be here. I just want to say thank you to the city of Hopkinsville for having us out on this beautiful farm in Kentucky, and we're just all really excited.
Yeah, definitely. It's a lot of fun. The light's starting to fade, and the excitement's getting bigger. We are at the point of greatest eclipse here at Hopkinsville. Renee, tell us a little bit, what's the significance of that?
Well, the point of greatest eclipse is actually a point in time when the axis of the moon's shadow is pointed most directly towards the center of the Earth. Great. So we are at the point on the surface of the Earth where that time occurs.
Exactly. The shadow will actually be more circular here than anywhere else in the country, correct?
That's right. And it's getting really dim, and we are just so close. It's incredible.
Yeah, this is amazing. We can't wait to break out in the darkness. We've got our glasses out. We've been looking up at it. You can see now on the screen our live telescope view, and this is just amazing. Everybody is really enjoying it. We've got people from all over Kentucky, people from all over the world have joined us here, as this is Eclipseville, USA, and we are just a few minutes away from total totality. But before we get to that point, Renee, tell us, you're a planetary scientist and you specialize in the moon, a lunar scientist. How does the eclipse really speak to what you do?
Well, it is pretty cool to look up there, and when you're seeing that sun get dimmer and dimmer, it's because the moon is up there. Right. And I like to tell everyone that you're really looking at the moon when you're watching a solar eclipse, and it's just getting dim, and it's starting to get a lot cooler too. Yeah, it's incredible.
Crazy. This is my first solar eclipse. Renee, have you ever experienced one?
This is my first total eclipse too. I've seen partial eclipses, but I've never had a chance to see totality before, and I'm just so excited.
It's amazing. The light is starting to fade as the moon steps in front of the sun here, and it's already just a really eerie feeling here, getting dark in the middle of the day. But we're really excited about it, and we're just a few seconds away. I've lost my counter, but I'm going to look back at the sun while I still have the opportunity. Wow, that is absolutely amazing. We're down to just a thin sliver of the sun. Renee, what do you think about this?
I can't believe it. It's just, it looks incredible, and it really is starting to get dim, and nobody even needs their sunglasses, just your eclipse glasses, and you can see that beautiful crescent sun.
Wow, this is absolutely amazing.
We're just really looking forward to that for a chance. We got no clouds here in the sky, and you can see some airplanes up there, but that sun is just getting smaller and smaller.
Yeah, it's definitely a Hopkinsville, Kentucky Chamber of Commerce sponsored day here in Eclipseville. There's not a cloud in the sky, and it's amazing how it's gotten so much cooler here since the sun started covering up started being covered.
Yeah, it's nice to have a break from that hot southern sun.
Yeah, definitely. We've been sweating it out a couple days here in Hopkinsville, getting ready for this.
We're getting really close now.
So what exactly are we looking at here, Renee?
Well, we're just about close to 100%. It's just getting smaller and smaller, and it's getting dimmer and dimmer, and hopefully soon we'll have a chance to see those Bailey's beads and that diamond ring. Right. That's when you can actually see the light shining through the moon's valleys. And the moon's not a perfectly smooth sphere. It's got that rugged surface, and you can see those sun rays shining through those mountains and valleys and craters.
Wow.
It's looking like we're about 1 minute out now, and it's just getting smaller and smaller.
Wow, this is amazing.
The crowd's getting really excited too.
Hey guys, who back there is excited for the solar eclipse? Wow, it's getting closer.
Wow. It's just getting really close to nighttime. It's incredible. It's like very dim.
Definitely it feels like dawn or dusk here in Hopkinsville right now as it's getting closer.
Come on!
And you can see on our feed, there's that tiny, tiny little sliver left to go. And it's really starting to get dark now. Wow. It's like dust.
Gracious.
And you can see the pink color around the horizon. Oh, it's like a sunset. It's beautiful. It's going. It's going. Just that tiny, tiny last sliver. Oh, my goodness.
And we are in total solar eclipse, and this is absolutely breathtaking.
Yeah, you can see the corona, that beautiful white wispy crown coming out from the sun in all directions. And we can see airplanes, and I think I see Jupiter in the sky over there. I think I can see Jupiter.
Wow.
And I see other planets too, and stars.
I can only imagine in ancient times what this must have been like.
I know.
Out of nowhere. I am covered in head to toe in goosebumps. A complete chill.
I know, I am too.
Body.
I just can't believe we finally got a chance to see it. I mean, it's one thing to read about it, but it's another thing when you get to see it yourself with your own eyes.
Guys, we're going to take a break here just a second. We're going to step back and fully enjoy this and hope you enjoy our feed on the telescope. Wow, here in Eclipseville, it has definitely lived up to
And now
its
we're getting
name.
that diamond
Here we
ring
go.
on the
We've
way
got it
out.
coming back. The moon is stepping aside
And
from the
now,
sun. It is getting
totality's over.
brighter. Totality has finished here at Hopkinsville. Wow, that was absolutely amazing, Renee. Can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Wow, this is amazing. We can see the birds flying around in the
we can
distance.
see the sun starting to come out, and it's getting bright again.
This is amazing.
It's really a once-in-a-lifetime opportunity
Yeah,
until the next
definitely.
eclipse
Yeah,
that we'll
exactly.
have only 6 years away. We get to see it again.
Wow, we'll be there.
Yeah.
We will be making
Without
our
a
way.
doubt. I think I'm hooked. I'm an addict.
We have sat in meetings preparing for this for the last 2 or 3 months, and now that it's actually here, it's completely 100% lived up to its billing, and I can't imagine, I can't believe what just happened.
It was just amazing. We were so worried about the weather and the, the broadcast and making sure our telescope was set up and everything went smooth, and we just had a blast.
Wow, this has been absolutely amazing. Folks, we have really enjoyed it. It's been a great time here at Hopkinsville, here at Eclipseville, USA. Now time for us to send it back to Clarksville, Tennessee, where our good friend Chris Blair is standing by for their reaction to the eclipse. Chris?
Well, I think he meant Charleston, not Clarksville. So let's bring it back here at Eclipse Central. There's only one Eclipse Central, and it's here in Charleston. Yeah, okay, so the hits just keep on coming through the eyes of NASA. Now, let's continue. Now, these are going to be pre-recorded views from the high-altitude WP-57 aircraft. They soar high above the clouds that could potentially block the views of today's eclipse. And they're chasing the total solar eclipse. They're mid-wing, long-range aircraft used to conduct high-altitude research. So, let's go to these pre-recorded views.
Yeah. Yeah.
Okay.
Yeah.
What are we seeing here, Alex?
So right now we're looking at these specially fitted cameras. They're on the nose cone of the WB-57, and these are designed to look at the corona, and they're also designed to look at Mercury. They're taking thousands of images every minute and processing this data to give us an extended view, because up there at 50,000 feet, it's 20 to 30 times darker than it is here on the Earth. Because there's a lot less scattered light. So this is a really unique opportunity. As those two planes fly in tandem, they give us about 8 or more minutes of the view of the corona. Now, the other thing they're actually looking at is, because they're so high up, it's very cold, and that allows them to take infrared observations. And in this case, Mercury is very close to the sun, and they can take infrared observations of Mercury to see the temperature change as Mercury is rotating.
That's amazing. So we're going to come back with that. But let's go, now let's go to Clarksville and see what's going on there.
Go, Chris. All right, thanks and welcome back. We're excited to highlight some of the student science and the STEM aspect of this solar eclipse. We have several students joining us right now. Would you please tell our audience your name and what school you go to?
My name's Eliza Dellert. I'm from the University of Alabama, Huntsville.
And what club or group are you with?
I'm actually with the Space Hardware Club.
All right, and you guys have been launching balloons all day today. Tell us about the scientific payloads and the instrumentation.
I walk on water. So you can leap right over that.
No better way than to lose your eyes.
You went to Atlanta and back? I don't need to push
Okay. This is a early field play.
History trick.
Yeah, that's don't you mean that science?
Yeah, hold up. Yeah, that's an automatic 8, Mr. Baldwin.
How about the view, guys? What do you think about the view, huh? How about the view?
Good view. Yeah, this is a good quiz grade. No, this is an automatic A for the first semester.
Do you think my class teachers would be impressed and like rate them?
I think they'll be impressed if you like take a selfie like what are you doing since in golf actually. Yeah, of course.
So, I'm gonna go to class. I'm like, you can't film me. I'm not a vice president.
Appreciate the opportunity. We're Facebook buddies. We're Facebook buddies.
I have selfies. These are going to be
let's do one more shot.
Don't get paint on.
Hey everybody, you want to get a picture with the astronaut, right?
Oh yeah. Oh yes.
Yeah. Okay, let's get another group shot.
Can
you get on the other side?
Get on him, right?
Slide on the other side of her. Okay. We're good. Go short. All right, give her a... No, you're perfect. You're perfect. Here we go. Everybody look straight ahead. Don't anybody look up.
Don't look up. Some of you can come down closer in front. Yep. All of you get close together.
Yeah, you use those two guitars.
Okay?
Great. Now, what's my microphone?
Wow.
Did we get one with your phone? Here, hand him your phone. We'll take one.
Yeah, my phone's good.
Yeah, Zach will get it. Okay.
You know, it's when I'm looking at the eclipse, I'm just thinking, people walked on that moon. Isn't that amazing? How far away it is? It's staggering.
Thank you.
Thank you.
Thank you.
Great. Make sure you send it to us. Yes.
So just
I
think
have
about people
actually.
walking on the
I have.
surface of the moon. It's so far away.
Very special place.
That is.
Very historic, but very much in use, very active. Continuous scientific research here.
Just come over, look at the stars at some point.
We have come over and we've toured, and we're just awful proud of the job the Navy does here. We really are. But I'm remembering, can I say, so 1979 was the last eclipse. I remember punching a hole in a piece of paper and cardboard. And I was in my backyard. Maureen's asking me, she's from Indiana. And then we watched the eclipse. You can do that.
Absolutely.
You can watch the shadow of the eclipse.
Hundreds of people doing it right now.
On a piece of paper. If you punch a hole in a piece of paper, because I didn't have these really cool glasses. Because you're just going to wear these now. You're just going to, this is your new look.
You're gonna run into a wall if you wear them though, because they're really dark.
They're really dark.
You look stylish when you do.
It's just amazing.
Oh, you got
That's great.
I want to look up so bad.
So cool.
Well, thanks everybody. Great job. Proud of all.
I really want to look up so bad. But I need my eyesight.
No, we got one. We're good.
Yeah. I feel like a dragon about you. He's fun. He's a lot of fun.
Thanks again. Great job.